All right, lecture 7, simple distillation, and some topics about the vapor pressure and azeotropes. So one thing about positive azeotrope is that let me annotate, is that one shortcut to remember what a positive azeotrope is the point where the dew points and the other point, I forgot what it is. Let me go check it real quick. Station bubble point. Yep. Thank you. Let me exit the. Okay, yeah. And let me get my pen out. Dew point and bubble point. The intersection is the positive azeotrope, would be which is the lowest point. If he asks about negative, it's basically the reverse. You should be somewhere at the top. And that one will be your let me get my pen out. Okay, yeah. And that one will be your negative azeotrope. And that one's PA. Yeah, open. The same is open book. And then just based on this information, the question asks which of the following temperature is the azeotrope? And it says A. I notice a problem. I don't have the temperature up here. Which of the following temperature is the boiling point of the azeotrope of this form, and water forms the azeotrope, which is following point. Yeah, I'm missing information here. It should be 82, I believe. This is from spring 2016.
Well, it tells you the boiling point in the question, so.
Yes.
So the positive one is the one with the lower boiling point, and the negative one is the one with the highest boiling point.
Right. So assume that is the lowest. Then if it tells you guys, then yes, pick 80 if that one's the lowest. But if that one's 82, then you pick 82. And then here's the next question. What will be the lower boiling point from the simple distillation? So the question is asking that you have a solution of 98% ethanol and 2% water. And when you distill it, you will get this curve. And it asks what would be the azeotrope, or the lower boiling fraction is just basically the lowest point. Of the graph. Yeah. Yep. The temperature will be at 82. The temperature will be at 78.2. And there will be a lower fraction because that's our azeotrope. The lowest point where the mixture distills out. And then we have another question, and I will leave this guys for you guys to figure out.
On the last question, why did they mark 4.4?
Oh, that's the mole fraction. Let me go back. Yep. And let me grab my pen out. 4.4. That's the 4.4% of water.
We're interested in
4.4%. 4.4% of water out of the 2% inside the RBF.
Oh, I thought so. That's what we're analyzing. I thought we were interested in 2%.
Now the entire one is 2%.
Oh, okay.
And the 4.4% is the 4.4% of the 2%.
Okay.
Yes. Kind of confusing at first. Okay. Next one. The question asks if you distill a mixture that has 60 more percent of methanol in chloroform. So you again, we have S of 60% of methanol in chloroform, and we are distilling it. That means that from 0 to 1, there's 60% methanol. And if you distill this, which will come out first? It has to be a lowest point. Yep, C. This is the point where we start to see, so this is 0.3, and it's around 0.35. Because this is the lowest temperature you're gonna see, and this will come out first. Lowest temp comes out first. And before I move into boiling point, everybody get the idea of azeotrope?
Wait, can you please explain why it's C and not D?
So D, 60%. So again, the
No, D is
question is
35% of chloroform.
But yeah. So the question is asking you to distill 60% methanol in chloroform in 100% of chloroform. You want to distill that, and the chart basically tells that at 35, so 35% of your 60% of your methanol, this will be the lowest point. So from 0 to 1, the entire is 60%.
That
methanol.
makes sense, but why is it? Can you explain why methanol is the what will distill first and not chloroform?
So chloroform is 100%, 0% mole fraction. So here, this is pure chloroform. And this is pure methanol. And the one that distills first is the lowest boiling point, right? Whichever mixture has the lowest temperature.
Yeah.
And that is the composition of methanol in chloroform.
Oh, okay. I see. All right. Thank you.
Yep. All right. Next. Annotate. Yeah. It's basically because it's the lowest point. And then boiling point. So stronger intermolecular bonds will have a higher boiling point, and we can see that in pentane we only have van der Waals, which is hydrocarbons. And then ether, we have this dipole, but it's being kind of canceled, so it's really weak. It's been canceled, so it's a weak dipole. And then in butanol, we have a hydrogen bonding pointing this way, and it can also form other hydrogen bonds. So that's weak, second, third, and strongest. And this ionic bond, which is the strongest inside this trend. And with this information, which one has the highest boiling point? And I want you guys to list out what are the bonds that exist here, like is it dipole, hydrogen bonding, or something else.
How does molecular weight affect boiling point again?
The molecular boiling point only affects the molecular weight only affects the boiling point if the molecule has the same functional group. So suppose I have a composite, have a acetic acid, and then I have added another carbon here, and I added another one, and so on. The chain keeps going. The chain keeps growing. The more chains they got, higher the boiling point. It only works if the functional group is the same. If the groups are different, then this rule doesn't apply. Yep. And can you tell me why? Shenqian? Why B is the highest boiling point?
Because of the OH bounding.
Right. The highest, the strongest intramolecular bond we observe here is the hydrogen bond. And let me list out. We have two H bond. And as I discussed before, ether, it has a weak dipole. And for ethyl acetate, which is the structure in D, we have this kind of resonance, and we have a dipole and dipole. So this is a stronger dipole interaction. And a cyanide is more electronegative than carbon, so we have dipole moments going this way. So if I will have to write them out, C will be weaker than A and weaker than D and then weaker than B. Next, same thing here, but maybe more complicated. Primary amine is stronger than secondary, and stronger than tertiary. Yep, it is D. You got any explanations?
Could it be because of the hydrogen?
Consider the what?
Because of the hydrogen bonding?
So that's one of the reasons. The main route, I will, yeah, if you guys have time, you can list everything out, but when it's time is short, and you confirm that this is the highest, it has the most hydrogen bonding, then it's good. This one is tertiary amine, which is the lowest among B, D, and E. So I can rank this out. This is primary amine, and this is secondary, and this tertiary. This is a strong dipole compared to ethyl acetate, because the electron can actually go up. So we will have a negative here and positive here. And we'll have C as the we'll have ether as our lowest boiling point. Primary, secondary, tertiary. And next, which one will have the highest boiling point? And here's some notes. Amine is not the same as amide. And one more note. Amide is stronger than amine. And you guys can also list out what are the forces that participated in each molecule. Can anyone tell me what's the lowest boiling point of the compound? Yep, it's 4. So we can cross this out because they don't have 4. And now we just have to determine which one is the highest, 1 or 5. Yeah, 8. So for 4, it only has 1 weak dipole. This one has 2. That's why 2 is stronger than 4. And then compare 5 and 3. This one is tertiary amine. This is primary. So that's why 3 is stronger than 5. And then we have our amide, which is the strongest. So that's why it's 8. You guys got that? Okay. And then we can move on to boiling point. So boiling of a compound only occurs when the external pressure equals to the atmospheric pressure. Oh, sorry. The boiling point only occurs when the vapor pressure of the liquid is equal to the external pressure. Otherwise, boiling will not occur. And some cases, they might just evaporate. And back to the question, what forces were in 1 from the last question? So in 1, let me grab my pen out. We have this amide. Strong dipole. And one more thing, this one is not much of a hydrogen bond because it's very basic. And if you want to interact it with other molecules here, I'll put N here, and O, and H. The effect might not be obvious, but this kind of bond is actually weaker than amide because of the resonance. And amide bond is stronger than amide. This is just a trend. So we have amide is strong dipole, and this one is just mainly amine and weak dipole. And here's one of the question. The boiling point of a liquid under vacuum. Usually PV ideal gas law works for this case. And we decrease the pressure. Yep, it's E. We can almost cross this straight out and leave us D and E. And D decreases because the vapor pressure of the liquid increases. No, boiling only occurs when the vapor pressure in the liquid and the external pressure is equals. So this is a really important definition you guys have to remember. Okay, this one. This is a new content that Professor Rudik included in the lecture this year. It wasn't there before. Sorry, it's only E. Yeah. So the trend is like this. Whenever you have when you are collecting on the compound, let me grab a different color. Whenever you have a compound here, and it boils, reaches its bubble point, you draw a straight line through. This is the point where you will collect in the apparatus. So you have your distillation. This is pretty much your bubble point. And whatever you collected is the dew point. And this two has to be the same. And once you drop back down, this is where you collected. And let me repeat the composition of the mixture at the beginning. Suppose this is 2.5, 25%. It starts to boil. And this is where you read. But by the moment you collect it, it'll be 3, 4, 5, it'll be 55%. Because there's this gap of area of room that the liquid can start slowly becomes vapors. And then by a point where they reaches its dew point, they will go down. And this is the question that can be helpful, which is from summer 2016 exam. I found it on Course Hero. So we have a mixture of A and B distilled gives it a split that has an approximate composition of 75% A. So 75% A. Right here. What was the approximate composition of the mixture before distillation? So at the end, it was 75%. What was the initial? It has to go from low to high. Yep, you got it. So I draw this line up, go over there, and go back down, 35%. So this is basically the reverse of what we had before. We have, this is our starting point. We draw a straight line across, and then go back down, that will be the end. But when we do the reverse, this is our beginning. And that's why it's 35%. And question number 2, which compound has the smaller vapor pressure, A or B? So smaller vapor pressure. means high boiling point. And yep, Antonio got it. B has the highest lower point, highest boiling point. Which is corresponding to small vapor pressure. Compound A has the highest boiling vapor pressure, and therefore it has low BP. That's the trend here. Okay. And any questions?
Can you go over again how you relate vapor pressure to the graph?
I don't have the complete explanation for it, but essentially, smaller vapor pressure is equal to high boiling point, and then higher vapor pressure is equal to low boiling point. Just keep this in mind.
What were you saying about low to high? You have written
Like which part?
you have written on the left low arrow high.
Oh, low to high. Oh, low composition, low percent to high percent.
How
So
do
the
you?
initial should be low. At the end, it should be high.
I have another question. How do
Yeah.
you know like which compound actually has a smaller vapor pressure? Looking at the chart.
Looking at the chart, you look at the end.
Okay.
So the smaller vapor pressure has the highest boiling point, and this is 100% B.
Oh, okay, okay. That makes sense. Thank you.
Yeah. Right.
People are saying, I think people are saying it might be B.
Yeah, they got it. It's B.
It's 45.
For question number 2.
Oh, for question 2, okay.
Yeah, for 1 is A. We know what the end is, and then we just do the reverse. That one goes up to the left, goes down. The initial is 35%. For A at the end, that means it's boiling A lower, so that means B has a smaller vapor pressure. Yeah. That's one way. That's one way to think about it. And I'm not sure how will Dr. Rudick explain it, but yeah. But after all, this will be the end of lecture 7. And if I have any questions, please let me know.